Before we start to explore example 11, pause the video now and take a minute to read through the scenario that is the context of this question. Now I believe you have read through the opening paragraph for this question. Let's go through some of the important details about this question. So the first detail that strikes me is that we are throwing a fair six-sided die, and especially the word fair. This would suggest that each side of the die has the same probability of 1/6 of obtaining the side. Next, the player is allowed to throw the die at most 3 times, and the player wins the game if he obtains a 6. Lastly, importantly, we need to realize that the game ends regardless of all other remaining throws when either a 6 is obtained or the die has been rolled all 3 times. Now this looks very similar to a probability question that we have seen before that would involve a tree diagram, because there is a sequence of events of rolling a die 3 times. And since we are only interested in whether a 6 is obtained or not, our tree diagram will look something like this. Right? If a 6 is obtained at any of the throw, the game ends, and so the tree doesn't continue on. But if it's not a 6, the tree will continue on to the next level, where the second throw will be done. And if it's still not a 6 at the second throw, it will go on to the third throw. But regardless of the result of the third throw, the game will end. Hence, it could either be ending at the first game, ending at the second game, or you end at the third game. Now let's read further on. There is a random variable that is being defined for us. The random variable x is being defined as the number of throws of not obtaining a 6 in the game. Okay, take note. A little bit tricky here is about not obtaining a 6. So let's just see what does it mean. Now this question is quite tiny. It tells us that x takes values of 0, 1, 2, or 3. So for example, let me start off with the probability of x equals to 0. What does it mean by the probability that x equals to 0? Right, so since x is the number of throws of not obtaining a 6, that means that x equals to 0 means that we have 0 throw of not obtaining a 6. Right, let me write that down. So this is 0 throw of not obtaining a 6. And how can the game be such that I have 0 throw of not obtaining a 6? This could only happen if I win right from the first throw. That means that on the first throw, the player throws a 6, and the game stops, and hence the entire game does not have any non-6 at all. Right, so from the tree diagram, to win from the first game is to get 6 from the first game, which is simply 1/6. Now, with this tree diagram that has been drawn, could you attempt to find the probability of the remaining x values and hence fill in the probability distribution of x?